Welcome to Jimbos Garage.
Good afternoon, everyone. Welcome back to the shop. Well, today I'm going to be making an aluminum ramp for a scissor lift. We're going to be using this 2" by 6" rectangular tubing for the frame, and I've got some 1/4" aluminum diamond plate for the surface, and I've got some 1" round aluminum bar stock, and we'll use that for a handle on either side of this ramp. Be a great little project. Let's get started on today's video. All right, so we're starting out here with some 2" by 6" rectangular tubing here, aluminum, and you can see that it doesn't quite get through my saw. It's a little bit too much for it, so I cut as much through as I can, and then I'm just cleaning these up with the cutoff wheel. You can see I can get down so far, but can't get all the way through. But this worked out pretty good. Just cleaning these edges up. It's not very often that it doesn't get through. You know, I recently did a video here. I think my last video was a comparison saw between the Fine Slugger and the Evolution. There was a clip there that it showed me not cutting all the way through on a 45. Well, I don't know what it is. I must have had the stop set up there, but there's no problems. This you'll see a little bit later on. This has no problems cutting through. You know, there's an adjustment on the table that you can adjust back a couple of inches, and allows you to cut through no problems. All right, so here I need to cut on a little bit of an angle. This is going to be the supports that are going to go in the center part of the ramp, and I was able to get 2 pieces out of 1 piece here. Did the math right, and what do you know? I was able to get them both. A little bit of cheating and adjusting. They gave me some flexibility on this ramp. They said somewhere about 6.5 inches, give or take 1/8 of an inch. So I gave and took that 1/8 of an inch in order to get both pieces out of one of these 2x6. You know, the skill saw works pretty good for something like this. You can see it's just a long template that I've got. That's a straight edge. And just clamping a straight edge up, and just be sure that you're nice and secure. The saw actually runs through there pretty good, and not only on aluminum, it cuts pretty good on mild steel as well. I think it was a total of 5 pieces that I need. Obviously 2 on the outside, 3 on the inside. This particular scissor lift is going to be going on this, I believe, is about 2,600 pounds, and they wanted to be sure that it was going to be strong enough to be able to support it, yet light enough to be able to maneuver around. You can see that I've got all 5 pieces put together right there, and they were cut a little bit unevenly. They weren't cut exactly, and so I was able to just take my flap disc and sandwich them together and go along and just trim everything up nice and even. Yeah, I've got that piece of beeswax right there. By putting that on the flap disc, it works really well. Keeps everything nice and sharp. Nothing loads up with the aluminum, and it really does a good job. You know, that beeswax is fairly inexpensive. I picked the pack up on Amazon. I'll put a link in the description for that. Pretty handy to have around the shop. All right, and then right here you can see I'm just trimming off the edges here to make everything nice and smooth and nice and flat. And then it's time for a little bit of assembly. Got the table dogs in place to get a perfect 90 degree. That's a good starting point. And then the pieces on the inside here. All right, so now it's time for some supports to the inside. Now this is some 2x4 rectangular tubing right here, 1/8 inch. And you can see no problems cutting through there. Now this is going to be going about 2/3 up from the ramp, and that's going to provide some support there. And then I've got some 2x2 material right here that'll be on the bottom third. That's going to give some equal support all the way around. I don't think I'm going to have any issues at all here. You know, it's a lot of cutting and a lot of welding, but it's going to be fun. So first thing I want to do is secure everything I can down in place, get everything nice and square. And with this, I'm probably going to use just about every clamp that I have in the shop, and then some, to get everything. You want to hold everything in place. I just don't want anything to move around. For this, I decided to operate off the HTP Invertig 313 AC/DC machine. You know, I recently did a project not too long ago that I did some aluminum MIG, and that was fine and fun. And this probably would have been a good candidate for that as well. But I wanted to hone my skills a little bit with the 313. I've had the machine now for probably 6 months. Done a lot of work with it, but no extensive type of work. And so this is what I choose to do on this one right here. Just to hone my TIG welding skills with aluminum. I mean, if you don't do it every day like I don't, it's nice to get some good practice in. All right, and then you can see there's the 2x4s and the 2x2s, and that's kind of how they're going to be spaced together. And with the menagerie of clamps and holding everything down nice and square, now it's time to go ahead and start tacking in and kind of securing everything in place. All right, so I'm using some like 3/32 to 1/8 inch filler material here. There are some gaps that are a little bit big, and so that thicker material helps to fill those in. But you know, it's all about the settings too. You know, once you get the settings just right, it really works good. It took me just a couple minutes to get things figured out, and once the settings got where they needed to be, everything is nice and smooth. Running 100% argon here, and about 20-25 CFH, and I've got it cranked up to about 200 amps. That seemed to be the sweet spot for what I'm doing right here. So a lot of tacking, be sure everything is held in place, and then I'll be able to take these clamps off and finish welding it all the way around. You know, I like to use this flex lock TIG head from CK, TIG torch from CK, because it gives you a lot of flexibility. You know, you're able to twist and turn and just get into places where you normally couldn't. And I found that to be very useful. As a matter of fact, I've got the flex lock set up on both the 221 and the 313, both my air-cooled and water-cooled torches. I like it that much. It's that much more easier to maneuver. All right, so here we go. This is going to be the welding fest right here. You know, again, maybe the MIG welding would have been a better option, but this is just something I wanted to do. After all, you're not going to get good if you don't practice. One thing I did notice as I was doing this is, boy, it was starting to get a little hot, and you can see I've added the TIG finger in there, and not only just to help keep things cool, but also it allows me to just slide right along there nicely when I'm doing long welds like this. You know, I was worried a little bit putting so much heat into this about a little bit of deflection. Thought maybe I would get some warping out of this, and I did. A little bit, not too much though, and it's not going to be anything that's going to affect the outcome of this ramp at all. It's still going to be just fine. But yeah, there was a little bit of warpage there, maybe about 1/8 of an inch or so, but not much more than that. That's to be expected when you're dumping so much heat into a small area like this. So here I'm jumping back and forth from 3/32 to 1/8 filler rod, depending on what I'm having to do, and adjusting the amps a little bit accordingly to make everything happen. You know, it's just a lot of welding. You can imagine you got both sides here, plus you flip it around, you got both sides there. One thing I'm not going to weld is the very bottom of it, because I want it to be perfectly flat, and there's going to be plenty of weld all the way around. Nothing's going to be moving around. The bottom part is not going to get any weld. It's going to be able to sit flush to the ground. You know, sometimes I didn't really show it too much right here, but you know, there's a lot. I went through a lot of filler metal. When you get down to the end, it's usually just 3 or 4 inches long. And I didn't really show it here, but I've done it before. Is where you I just bump those things together and add them all up, and you can create a couple more sticks. You know, and none of it goes to waste. And I think I've gone around the other side now, and we're now working on the opposite side. You know, not too bad for a guy that doesn't do a lot of aluminum MIG. All right, so there's the diamond plate right there, and So I've had this sheared with the my metal supply company. I had them cut it to the exact length. I believe it's 40 by 48, and that's what we made everything. You know, they just have that capability there. All right, with this in place, I'm going to switch gears and jump over to the ProPulse 300 with the aluminum MIG setup on it, and I'm going to be able to finish this out with that by clamping the plate down. You know, so some 1/4 inch thick plate, and there's some gaps right here trying to fill. And I'm telling you what, no problems at all with the ProPulse 300 and this aluminum MIG. It's a good application for that. It was quick and easy and fast, and got a lot done. All right, with the sides all welded in place, and I got some cross supports in there to help hold the plate down to the frame. It's time to just get in there and just get some weld on both sides to just secure that in place. Now you can imagine trying to do this with the TIG torch. It might have been a little bit difficult to get into some of those spots, you know, to get the torch head in there plus the filler wire in there. This was just a much better and easier form of doing this, especially in a situation like this right here. Really tight in there. All right, getting right down to the end right here and just finishing up these welds. You know, just one on either side. This is just going to be enough to just hold everything in place, and it's going to work. You know, obviously we're not welding this thing all the way out, all the way around. It's not necessary. You know, this just sped up just maybe one time, so it's not too fast, but you can just see how quickly you can just go along here with the aluminum MIG and just catch everything. You know, it's just like MIG welding itself. It's just mild steel. It just lays right in there, and everything is just nice and smooth. Once you get the settings right, you know, that's the whole important thing with this too. You know, just trying to get it dialed in to what material thickness you're working with, and once you get that, then it really performs well. I think I was running about 50 or 60 CFH here, and somewhere right around 250, maybe 300 inches a minute on the wire feed speed, 35 thousandths to 4041, and that seemed to be the sweet spot. Seemed to work pretty good. After that was all done, I just wanted to round the edges up and kind of clean up those welds a little bit and kind of smooth things off. And then it was time for the handle. I decided to put a handle on either side. It's going to be about 14 inches long. It's going to stick out about 1.5 inches or so. I didn't want anything too bulky looking, but I did want something on either side. It could be a one-man moving around with a handle, or two guys can, you know, from either side. It's not very heavy, just kind of awkward. So a couple of handles here, cut it to 45. And you can see, here's a good example. We're talking about, you know, the last video and how it didn't cut all the way through in a 45. You can see it's just no problems right here. I just must have had to stop for some reason, stopping me from going all the way through, but there's definitely not a problem here. All right, once I got all the pieces cut out, just over the Burr King and kind of smooth up the edges a little bit. And then over to the welding table and set up a jig. You know, for something like this, you can see I've got a couple pieces of angle iron. I got them fastened down with the table dogs at a perfect 90 degree, and then clamped down with some fixture clamps, and that's just holding everything in place nice and tight so it can't move around. I want to go ahead and get as much weld as I can on both sides right here, and then I'm just going to unclamp it, flip it around, and get the other side. And you can see it still fits in there nice and tight, and it hasn't moved around, and that's the idea. You know, I learned the hard way, you know, in the past. You just, you know, things move around, things warp. I'm telling you, if you don't clamp them down properly, you get a lot of distortion. All right, so there you go. That's kind of what they look like, and I'm all done with this jig now. I'm going to get it all out of the way, and now I'll be able to finish up the welding right here. You know, I decided that my plan was to leave the weld here, not do anything with it, and just leave the nice clean TIG weld, and it looked good, but it just looked unfinished, and the outer edges right there kind of were a little sharp and a little sloppy looking. You know, the welds were fine, but it just didn't look right. And I decided that I thought maybe it would be best if I just kind of clean them up with a flat disc or something and make it, just touch them with a flat disc on the outer edge. That was my thought at first. All right, there's the two. And so, like I said, my thought at first was just to get in here and kind of clean that out. And then I said, oh yeah, that looks pretty good. Okay, I'm going to go with that. Well, I kept going and it's starting to look better and better and better. And so, I decided, well, I'll just go a little bit. I'm going to go a little bit longer here. Try some emery paper here and maybe smooth that up. And try to get that smoothed up to the next level, which worked out pretty good. But that just wasn't quite satisfying enough for me. I had to break out a flap disc with some, I had to break out a flap disc with a non-woven pad right here, and that kind of buffed things up quite a bit. This is stuff that I had from Mercer. Mercer's got all kinds of abrasive stuff that you can use, and this is something that I had ordered a while back for another project, and that stuff works pretty good, especially on aluminum. That did the trick right there. All right, so these handles right here, I decided to go ahead and put these in, and I'm going to be using my Champion hole saw right here. Now the first hole here, I believe, is 1 1/16", and then I'm just gonna you can see I just got the pilot hole on the other side. Now I couldn't go all the way through because of the collar it was hitting, so I switched down to a 1 inch. So the first hole, 1 1/16", pilot hole through the other side right there, and then switch over to the 1 inch, and then go ahead and finish that up. Just because I couldn't get the collar through. So no problem. Now that I got the hole drilled, this thing fits through all the way through to the other side, and I'm just going to prop this up and get it right where it needs to be. Now, the only problem with that 1 1/16", it's going to allow a little bit bigger of a gap to weld, but not too bad. Now, everything's nice and square. You can see that they're sticking through the other side right there, or almost. The one isn't. I maybe cut that one a little bit short, but it is even on the outside. This might have been a thing for the aluminum MIG, but I refuse. I'm still wanting to TIG weld this, still wanting to get some practice in, so that's the route that I went right here. It's a good way to see that flex lock work, and you twist that thing in every angle you possibly can in order to get around everything. It was kind of tight on the inside, but and it is going to be kind of tight right here as well. It's going to be tough to get around the outside. Yeah, this was a little bit tough right here. That's about as far as I can go until I can tip it up and get around the backside right here. You can see I took the filler rod, bent it at about a 90 degree just so I can get it back in behind there. And it was kind of tight fit back there, but got it done. And then on the outside right here, all the way around, you can see that I was fighting it a little bit. It was kind of tight, and I can only wrap my arm around so far. And I ended up getting as much as I could here, and then flipping it around to the other side and coming in from the other side to get it finished up. Getting awfully hot. I got that TIG finger up there trying to keep things nice and cool. No heat gets through there. Yeah, it's very comfortable. All right, so that was the one. Same thing on the other side right here. Just got those holes drilled, and then just popped this in and just finished up the welding on the other side. Look at the way I got this propped up. Sometimes you gotta do what you gotta do. A 4-foot level from my welding cart up to the top, clamped in to hold this thing in place while I take care of this. One-man operation. You don't have anybody around to help you hold things. You gotta do what you gotta do. All right, well there it is. All in all, this was a fun project. It was a lot of aluminum TIG, a lot of aluminum MIG. But I had a good time doing it. I hope you guys enjoyed it as well. Hey, if you guys are interested in checking out my website, if you're looking for some torch lead holders, or some table dogs, some merchandise over there, some shirts, some hats, feel free to check that out at JIMBO'SGarages.com. Also, I'm on Instagram and Facebook. Check us out for a lot of behind-the-scenes activities there as well. All right, guys, thanks for watching. We'll see you next week.
See you next time on Jimbo's Garage.